Welcome to the deep dive. Today, we're taking a bit of a shortcut, really, straight to the bedrock of professional safety management. We are diving into hazard identification and risk assessment, HIRA, and we're using a specific systematic industry standard, EHSAMP G07, as our map. So our mission here, it's to quickly cut through the noise, the jargon, and really grasp the analytical engine behind EHS. How do companies go from just seeing a danger to actually putting a number on it, and then, crucially, controlling it so it's acceptable? This is like where theory meets practice.
Absolutely, and it's vital to get that this isn't just paperwork. The real point of HRA, its core objective, it's all about consistency, making sure that risks, whether they're people, the public, the environment, they're reliably kept within what the organization can tolerate. And for project sites specifically, this isn't a one-off thing. It covers the whole life cycle. Planning, building, running, right through to taking it all down again.
Yeah. Right. And I think the elegance of a system like this is how it forces you. Really demand that you answer 5 specific questions. You have to tackle these before you start the work. First up, the hazard. Simple question, really. What can actually go wrong? Second, consequences. Okay, if it does go wrong, how bad could it be? We're talking a scratch or something catastrophic. Third, likelihood. How often might this bad thing actually happen? Is it daily? Once a decade? Fourth, risk. And that's just a combination, right?
Yeah.
Likelihood times consequences. And then finally, controls. What are we going to do now to manage that risk, to bring that score down?
Exactly. And before we even think about calculating, we need really solid definitions. It's key we separate these concepts properly.
Yeah.
So a hazard, think of it as just the source. Any source, situation, act, anything with the potential to cause harm.
Yeah.
Injury, illness, damage.
So like wet paint on the floor is a hazard.
Precisely. It has the potential to cause a slip. The potential is the key word. Now, risk, that's different. That's measurable. It's the combination, the likelihood of someone actually slipping on that wet paint, multiplied by how badly they might get hurt if they do.
Okay, got it. Hazard is the source. Risk is the calculation of probability and impact.
Correct. And the whole risk assessment itself, that's just the systematic process you follow. Find the hazard, analyze the risk tied to it, and then evaluate, the likelihood and the impact overall.
That clarity is, it's fundamental. The standard also makes you categorize the work itself, doesn't it?
It does. You've got routine work. That's your everyday stuff, happens frequently. And importantly, it must already have a safe work method, an SWM, documented for it.
And the other type.
Non-routine, NR. That covers occasional jobs, maybe one-offs, things that aren't part of the normal daily grind, or even unplanned stuff that crops up.
Okay, routine, non-routine. But you mentioned tolerance earlier. I think the absolute crux of this whole system is nailing the difference between what's okay and what's absolutely not. We're talking acceptable risk versus unacceptable risk.
Exactly that. Acceptable risk is, well, it's what the organization deems tolerable. Always keeping legal duties in mind, of course. Unacceptable risk, that's the showstopper. By definition, it has to be reduced. You cannot start the work until it's dealt with.
And are there automatic triggers for unacceptable?
Yes, and this is quite interesting. The standard flags 2 specific hazard types that automatically push the risk into the unacceptable zone no matter what the initial numbers say. These are legal concern, LC hazards, things directly tied to legal breaches and emergency hazards. If either of those is present, bam, unacceptable, needs immediate control.
Right, so the system has built-in red lines.
Definitely. And there's one more factor we have to consider right at the start. Uncertainty.
Uncertainty, how does that fit in?
Well, the framework explicitly calls it out as something that affects the assessment. Think about digging, right? You're on a new site. Maybe the maps showing underground pipes or cables are, incomplete, or maybe just old and unreliable. You're uncertain about where hazards might be lurking.
Ah, I see. So that lack of knowledge, that uncertainty itself becomes a factor in the risk. You have to account for it up front.
Precisely. It can significantly affect your initial ratings and what controls you decide you need.
Okay, that makes sense. So let's picture the site team. They're faced with a job. How do they actually, kick this HIRA process off? What's step 1 on the ground?
It's quite structured. The site execution team, the people doing the work, they select the job first. Then they list out every single activity and sub-activity involved. No cutting corners. Then they classify each one. Is this routine or non-routine?
Okay, so a detailed breakdown.
Yes. And that list becomes the input for the formal HIRA study. This study then gets reviewed, first by the site EHS person, the safety expert on site. And then, crucially, it needs approval from the project manager, or maybe even the project director. That signature is the formal sign-off saying, yes, we understand this risk and we have controlled it.
That approval step sounds key for accountability. Now, when they list those hazards, I understand they also classify how the hazard is present. Does it matter if it's always there or only sometimes?
Oh, absolutely. It dictates how you prepare. There are 3 categories for hazard presence. First is normal hazard, N. This is the one that just exists whenever you're doing the activity. Like if you're welding, sparks and fire risk are normal hazards. They come with the territory.
Okay, makes sense. What's X?
Then you have abnormal hazard, AB. Now, this is important. It does not normally exist when you're doing the job properly. It's not an emergency situation, but it might appear under abnormal conditions, like a machine breakdown. Or, very significantly, if someone decides to take a shortcut, bypass a safety procedure, that's an abnormal hazard arises from things going wrong, often human error or equipment failure.
Got it. So things you hope don't happen but might? And the third?
That's the emergency hazard. This is the big one. A hazard that could directly lead to a major emergency situation while the activity is being performed. Think catastrophic failure potential.
Right. So the assessment forces you to think beyond just the obvious immediate risks. And the scope seems incredibly broad. You mentioned the standard list, 16 types of OHS hazards?
That's right, 16 indicative types. It's designed to be comprehensive, to make teams think widely. You've got the ones you'd expect, sure, like gravity falls, slips, trips.
For chemical hazards, breathing stuff in, skin contact, lack of oxygen.
Exactly. But then it pushes further. It includes things like human factors or behavioral issues. That covers a huge range, from actual psychological issues affecting work right down to, fooling around, horseplay on site.
Wow, okay, that's drilling down into human behavior.
It is. And it goes even wider, looking outwards. It mandates assessing risks from natural calamity, earthquakes, floods, cyclones, you name it. And even demographic hazards. Things like stampedes, riots, arson, civil unrest, even terrorism, if that's a relevant context for the site. It forces a truly 360-degree view.
It really does. From a dropped tool to a riot, that comprehensive view must be what allows the transition from just identifying threats to actually, putting a number on them.
Precisely. Identifying is step one. Quantifying is where the analysis really kicks in. And the way we do that, the core calculation, is multiplying the severity rating, SR, by the likelihood rating, LR. That gives us our final risk score, which we just call R equals S times L, basically.
Okay, let's get into the engine room then. Those 2 scales, severity and likelihood, they both run from 1 to 5.
That's right, 5 points each.
So let's walk through severity SR first. This is about how bad the outcome could be if things go wrong, if controls fail. Level 1 is what? Negligible?
Pretty much. No effect or a trivial one. Think a near-miss event where nothing actually happened.
Okay.
L2. Minor injury. Something needing basic first aid, but the person is back to work quickly.
Level 3 sounds like a bigger jump.
It is. That's a lost time injury, an LTI. Someone needs hospitalization, they're off work. That's a serious event, impacts productivity, everything.
Right. And level 4?
Incapacity. We're talking major injury here, possibly permanent physical disability, still an LTI, but with life-changing consequences.
And level 5 is the worst case scenario.
Exactly.
Yeah.
Fatality. Catastrophic outcome.
Okay, so that's severity, from a near miss to a fatality. Now, the other side of the equation, likelihood, LR. How often might it happen? Also 1 to 5.
Yep, 1 to 5 again. Level 1 is almost impossible. Extremely unlikely to ever occur.
Level 2.
Very unlikely. Might happen, but perhaps only, say, yearly across similar activities.
Level 3 moves into possible.
Right. Possible suggests it's likely to occur perhaps monthly. Now it's becoming a regular possibility,
Level 4 is probable.
which means likely to occur weekly. Think about that frequency, something potentially harmful happening every week.
And level 5 is certain.
Or almost certain, likely to occur daily. If you have a hazard with high severity rated as certain to happen daily, you have a massive problem.
Yeah, that difference between, say, a 3 monthly and a 4 weekly feels huge in practical terms. That shift in perceived likelihood could really change the whole picture.
It absolutely does. And that's where the judgment and experience of the assessment team come in. So you multiply those 2 numbers, severity times likelihood, SRXLR.
And you get R, the risk score, somewhere between 1, which is 1 by 1, and 25, which is 5 by 5. What does that final number actually tell the project manager who has to sign off?
It gives them an immediate action threshold. The standard defines high risk as any score that's 10 or more.
10. Okay.
Moderate risk is a score of 4 or more, up to 9. And low risk is basically anything from 1 to 3.
So 10 is the magic number for high risk.
Essentially, yes. The real power here isn't just the number itself, it's that it imposes a quantitative scale on what can feel like subjective danger. It stops managers just waving away a risk because fixing it looks expensive or difficult. If that calculation, based on existing controls, comes out at 10 or higher, red light, stop. You cannot proceed as planned.
Okay, so that initial score is based on what's already in place. If it hits 10 or more, the team must then identify these things called opportunities. What are those exactly?
Opportunities is just the standards term for the additional control measures you need to implement, the things you have to do to bring that risk score down below 10 into the acceptable range.
And finding those opportunities, those extra controls, isn't just a brainstorm, is it? There's a specific order you have to follow.
Absolutely non-negotiable. There's a mandatory hierarchy of controls. You must consider them in this specific order, from most effective to least effective. This dictates how you should be thinking about solutions.
Okay, let's walk through that hierarchy. It's crucial for understanding how resources should be prioritized. What's at the very top? The best option.
Elimination. EL. Simple concept.
Yeah.
Just get rid of the hazard completely. If working at height is the risk, can you design the task so it happens at ground level instead? Eliminate the need to go up.
Right. Best option, but maybe not always possible. So if you can't eliminate
Should move to substitution,
Yeah.
SP. Replace the hazardous thing with something safer. Swap out a highly toxic chemical for a less toxic one, for example. Use water-based paint instead of solvent-based.
Okay, substitute. What's next on the list?
Engineering controls. EC. This is about changing the physical environment to reduce the risk. Things like installing machine guards, putting in local exhaust ventilation to suck away fumes, building safety barriers.
So physical changes to the workplace or equipment, still quite effective.
Generally, yes.
Mhm.
More reliable than relying on people's actions alone. Only after you've exhausted those do you move down to.
Administrative controls, AC.
Correct. This includes things like warning signs, safety procedures, specific training, job rotation to limit exposure time. Important, but relies heavily on people following the rules.
And dead last, the final resort.
Personnel protective equipment,
Yeah.
PE. Gloves, goggles, harnesses, respirators. It protects the worker if something goes wrong, but it doesn't remove the hazard itself. It's the last line of defense, and generally the least reliable over the long term.
That hierarchy makes perfect sense. It forces you towards fixing the problem, elimination, engineering, rather than just managing the symptoms, admin, PPE.
That's precisely the intent. Push for systemic, permanent fixes. And once the team identifies these opportunities, these new controls, they had to do the calculation again, right?
Yes, absolutely. A post-opportunity risk assessment is required. You have to recalculate the score with the new controls factored in to demonstrate that the expected risk score will be reduced to an acceptable level. You need to prove the fix works on paper before you implement it.
So it closes the loop. Assess, find unacceptable risk, identify controls using the hierarchy, prove they'll work, then implement.
This really sounds like a dynamic living process. Who holds the responsibility for keeping it all running smoothly on a project?
Well, the standard spreads it out, but with very clear roles. It starts right at the front line. Workmen, the people doing the job, they must understand the risks involved in their task. They must follow the control measures that have been put in place. And critically,
Yeah.
they have the explicit authority and responsibility to stop the work immediately if they feel the risk becomes unacceptable for any reason.
Yeah.
And they have to inform their supervisor right away. That's empowering the workforce.
That stop work authority is huge. Okay, what about supervisors and managers?
Site in charge and managers have a really important dual role. They need to communicate the risks clearly to everyone working under them, make sure the HRA findings are understood, and they also need to validate the process. They're responsible for checking that the controls identified in the HRA are actually adequate and being used effectively. They do this through things like safety observation tours or SOTs.
So they're checking reality against the plan. And higher up, the project manager?
The project manager or director holds the ultimate accountability. They need to provide the resources, time, money, people to actually implement the controls, especially the engineering ones, which might cost more. They also review the overall progress of the HIRA process and have to ensure that all relevant personnel are familiar with this standard and how it works.
So the HIRA isn't just a document you file away. It sounds like it actively drives other safety activities.
It absolutely should. It becomes the hub. It identifies where specific training is needed. Its findings should inform what the SOTs are looking for. And crucially, the HRA itself must be reviewed and revised. Whenever there's an incident, you go back to the HRA. Learnings from incidents feed back in. If the work method changes or new equipment is introduced, the HRA needs updating. It's meant to be a continuous improvement loop.
Not static, it learns and adapts.
Exactly. And connecting this back to the big picture, the overall management system. The real test of HRA's effectiveness is management buy-in and oversight. Good systems have mechanisms where maybe safety champions audit compliance annually. And importantly, leadership, those project directors, they should be reviewing key performance indicators, KPIs, related to HRA every single month.
Not just lagging indicators like accident rate.
No, leading indicators, proactive measures.
Right.
Things like how many HRAs were completed and improved this month, how many identified engineering controls were actually implemented. That shows proactive risk reduction, not just reaction.
So wrapping this up for you, the listener, what's the big takeaway? HRA, one done right, based on a standard like this, it's a structured analytical tool. It moves safety management away from guesswork or just gut feeling and gives you a quantifiable framework, that risk matrix, that 1 to 25 score. It forces a logical approach to managing potential dangers.
And it channels effort effectively, pushing towards eliminating hazards first. It provides documented evidence that risks are understood and are being actively managed down to a level the organization and regulators can accept.
It's about making the invisible visible and the subjective quantifiable.
Perfectly put. The whole system hinges on making risk transparent and measurable. It's the mechanism to ensure you stop hoping for safety and start engineering it based on data.
Which brings us to a final, perhaps slightly unsettling thought to leave you with, drawing directly from the standard's own concepts. We talked about uncertainty. If that standard defines uncertainty as a specific factor you must consider in your HRA, what level of uncertainty, what degree of not knowing about a hazard's existence or its exact location? Think about that buried, unmarked electrical cable again. At what point does that uncertainty become so significant that it forces the assessment team to jack up the initial risk score so high that perhaps the only acceptable control measure left, according to their own rules, is to simply stop the job before anyone even starts digging? Think about the power embedded in acknowledging what you don't know within this very analytical system. What does true uncertainty demand?